Hi everyone, welcome to the channel. Hope each and one of you is having a wonderful day. Today we'll be looking at this problem called product of array except self. And we're given an array of nums of n integers where n is greater than 1. And we want to return an array output such that output of I is equal to the product of all elements of nums except nums of I. So we see here this one is 24 because 2 times 3 is 6 times 4 is 24, and then 12 because 1 times 3 times 4, and then 8 we have 1 times 2 times 4, and that's 8, and then 6 we have 1 times 2 times 3. So a naive way to solve this problem is to find the total product, which is 24. And then each time as we iterate through the array, we divide by the current element. So 24 divided by 1 is 24, 24 divided by 2 is 12, 24 divided by 3 is 8, and 24 divided by 4 is 6. However, it says please solve without division, so we cannot use that idea. And we need to solve in O of n. Even though it is O of n runtime, we don't follow this constraint. So looking at the problem further, we can see the factors that are equaling to the output. So you see input. It's faster if I just copy and paste it. See our input here and our output here. And we could write in, let's have the indices, so it's easier to follow through. Yep. So for the 0th indice, we see the factors that are used are 2 times 3 times 4. And for the first indice, our factors are 1 times 3 times 4. Second indice, we have 1 times 2 times 4. And the third indice, we have 1 times 2 times 3. So what we notice here is if we were to do O of n, one pass, we see something that we could cache is here. No elements used. Well, what I meant by no elements used is we can notice a pattern, which is if we were to do one pass, we could say we use 1, which indicates no elements used. Then we could use 1 times the first element, which is 1 times 1. And then we could use 1 times 2 to include the first 2. And then we could use 1 times 1 times 2 times 3, which uses all the elements. So then we see that the last is complete. We get 6, which is the correct answer. And so first pass, we can get half of the, or part of the result. And we see this pattern where we get 1, and then 1 times 2, and then 1 times 2 times 3. All of this done in O of n time. Now if we go back and we do the second pass, we see that we can use no elements. Then we can use the last element, which is 4. And then we can use last element in second to last, which is 4 times 3. And then we can have 4 times 3 times 2. Oh. So if we combine the results from the first pass and the second pass, 1 times 4 times 3 times 2, this will equal 24. And then one times 3, and then we have 1 times 1 times 4 times 3, we get 12. And then for, let's only get 1 times 1 times 2 times 4, which is 8. Then 1 times 2 times 3, which is 6. So see our final output in the correct indices. We have the correct answers, and basically what happens is first pass, we are building up because we notice the pattern that each of the product's factors, here we use none. Well, what we're using here is we're not choosing any of the elements, but then when we choose one, we're actually using, actually it might be easier if I put the line on top. So for this one, first pass, not choosing any of the elements, but here, first pass, I'm getting the 1. Here, the first pass, I'm getting 1, 2. And then third pass, or first pass, but the last element, getting 1, 2, and 3. Now the second pass, I'm not getting any of, I'm not using any of the elements. Maybe star is not good. Let me try a different symbol. Okay. And then first pass, I'm using the last element, or second pass, going backwards, I'm using the last element, and then I use the last 2, then last 3, which is basically the whole array. So the red and the blue indicate the passes, each of which takes O of n. So our runtime is O of n plus O of n. So the overall big O of notation for runtime is O of n. And it says here that this output array does not count as extra space. So that means this algorithm is also constant in space. So now let's get into coding. So first thing is when we want to iterate this, we need to have the length. So n equals length of nums. It's up here. And next thing is, you know how here we're using 1, or we're caching the results. So it's 1, and then 1 times 1, 1 times 1 times 2, 1 times 1. So we'll call that p because it's a product. And we'll start at 1. And then we have output. We'll make it an array because that's our output array. And then we go I in range. We go up to n. This is our first pass underscored in red. First thing we do is we select no elements, which is basically choosing 1, because when you multiply the product by 1, it's basically mean you're not including the element, since the second number you multiply with, that will be the product, or it will be the product result. So we do output, and we append p. Now for the second element, we know we choose the element in the first indices, so then p equals p times nums of I. In this case, it would be nums of 0, and we see in the 0th position we have 1, so then p becomes 1. Then our output has 1, 1. And then the next one, nums of 1 would be multiplied by p, so it would be 2. So that's why here we would append 2. And then after that, we make nums of p 2, which is 2, multiplied by the next element, which is 3. So then we append 6 to nums. So at this point, our output array will be 1, 2, 1, 1, 2, 6. And then now we do our second pass. N minus 1 because, well, here we have 4 elements, so the indice is 3. We want to go backwards, and we end at -1 because the range, it goes up to minus -1. So we do minus 1 minus minus 1, it becomes 0, so we end at the 0th indice. And we use output of I. We get the last element, taking output of I, and we multiply by p. Now, note p right here, it actually equals 6, but we want to reset it back to p equals 1. So now when this does that, we get 6. We add equal to multiply by p, so it's still equal to 6. multiply it by p, which is 1, it still equals 6. And then, similarly like above, we multiply equal to nums of I. And the last one in nums is 4. So now p equals 4. Yes, now p equals 4. And then we do output of I. Now it's on 2. 2 times 4, which is 8. And then we multiply by the next nums, which is 2. Oh, actually the next one is 3. So now p is 12. And then we multiply by p with output of I, and that would be 12. So now we have 12. And then the last number, well, not the last number, but the next number is p equals 2, or the last number in nums of I, nums of 1 is 2. So now p equals 24. And then we do 24 times 1, which is 24. And so now we see our output is what we want. So that looks good. And so we return output. Now we need to clean up our comments. And clean up our work. And let's take a look at it just to make sure it's good. So n, first we get the nums, get the length. Now we have product p equals 1. We have our output array, iterate through, pending p each time, our product for the first pass, incrementing the product by calculating, including the next factor, reset product to 1, count backwards, including our value from second pass product with the first, and then incrementing our product and return output. Let's see if this is good. All right, looks good from there. Let's submit. Awesome. Looks like I can submit. Not too shabby. All right. Thank you guys for your time. Hope you guys had fun and learned as well. Follow me on social media if you like more content, and like and subscribe, and also share with people that you might think this will help and they might find it fun. And I hope you all enjoy the rest of your day.